Welcome to the OSID setup tutorial video. This video will provide an overview of how to install, configure, and test OSID projected beam smoke detectors. This is the OSID imager or receiver, and it features a view lens and a ball and socket assembly. The imager is powered by non-resettable 24-volt DC power and provides alarm and trouble relay contact outputs for interface to the fire alarm system. It is available in 10, 45, and 90-degree fields of view. The ball and socket lens assembly is easy to maneuver, both vertically and horizontally, for quick, simple alignment. This is the OSID emitter or transmitter, and it is similar in appearance to the imager. Each emitter projects a wide-angled beam containing a sequence of ultraviolet and infrared light pulses toward the imager. Like the imager, the emitter has a ball and socket assembly for quick, simple field alignment. This is the alignment tool, and it is required to properly install OSID imagers and emitters. To begin installation, carefully detach the front cover of the unit by using a flat blade screwdriver to gently pry the front cover away from the main assembly. Once the imager is opened, you can install and connect power and monitoring cables. You also can access dip switches for use for detector configuration. All imager settings are configured via dip switches found on the main board. The dip switches are used to set the desired number of emitters to be monitored by the imager, the imager's sensitivity settings, and latched or non-latched operation, as well as dust rejection. Refer to the OSID product guide for wiring and dip switch setting details, or simply look inside the imager front cover. This comes in handy if you need a quick reference for setup and commissioning. The wiring connections also can be found in the OSID product guide. Here you will find the necessary information on how to wire relays, power, and a lens heater if it is needed. Terminal blocks for relay and power can be found on the left side of the main board. The terminals for the heater are on the bottom, and the dip switches are along the right side. In this example, the imager will be configured for medium sensitivity and paired with a single emitter. It also will be set for latched operation. After mounting the imager and emitter, they are aligned by using the laser alignment tool. It is inserted in a slot directly below the lens. For startup, always begin with the emitter. Battery-powered emitters are activated by locking the optical sphere in place. Externally powered emitters activate after locking in and powering the unit. Using the laser alignment tool, point the laser directly at the OSID imager. Once the imager is aligned, rotate the tool clockwise approximately 1/4 turn to lock and activate the emitter. If activated correctly, the emitter will begin pulsing to communicate with the imager. Operation of the emitter can be verified by looking at the emitter lens. It will flash periodically to show its status. Next, the imager is aligned. Using the laser alignment tool, point the laser directly at the emitter. When the imager is aligned, rotate the tool clockwise approximately 1/4 turn to lock and activate the training mode. Training mode can last up to 10 minutes. The sensitivity should be tested using a calibrated method such as a smoke test, or by inserting a special optical filter into the beam path of each emitter. This filter can be ordered from Xtralis. Only one emitter should be tested at a time. The filter should be placed directly in front of the emitter. To verify proper fault reporting, place an opaque object in front of the emitter to simulate an obstruction. This is the OSID USB cable. It is used to connect the imager to a laptop computer equipped with the OSID Diagnostic Tools software. The software is used to aid with commissioning of the OSID system during training mode and to diagnose any subsequent faults. The interface cable is connected to the imager via the jack plug socket on the underside of the imager. The USB connector end of the cable is connected to the laptop USB port. After powering up the imager, it automatically searches for emitters in its field of view to record their position and timing. During this time, the trouble LED on the imager will flash to indicate the detector is in training mode. Now let's look at the OSID diagnostic tool. The OSID diagnostic tool allows real-time trending of alarm and trouble conditions. There also is a video feature that displays the imager's field of view and associated emitters. While the imager is in training mode, emitters in the field of view will appear as flashing yellow dots on the screen. The emitter will continue to flash as a yellow dot if a fault is present. The emitter will change to a solid green dot once the system is normal. The sensitivity should be tested using a calibrated method such as a smoke test, or by inserting a special optical filter into the beam path of each emitter. This filter can be ordered from Xtralis. Only one emitter should be tested at a time. The filter should be placed directly in front of the emitter. Once the test filter blocks the ultraviolet and infrared beams, the imager will generate an alarm. If you select the video view in the diagnostic tool, the emitter will appear as a red dot to indicate a fire alarm. To To verify proper fault reporting, place an opaque object in front of the emitter to simulate an obstruction. Once an obstruction is detected, the imager will raise a fault condition.